thank you and Rachel for being here. I know it's been a long day, so anyway, so I've been thinking about this stuff for some time, and in particular, I was interested in providing a general theory of metaphysical indeterminacy. I tried a couple of strategies, and one of my main goals was to come up with a reductive theory, because metaphysical indeterminacy, unlike other notions, seems kind of mysterious, and many philosophers for a long time tried to argue, or maybe often just stated that it doesn't make any sense insofar that it's either trivially false or incoherent. A lot of work has been done to show that it is at least coherent, but some of this work has been unable, in my opinion, to fully clarify what metaphysical indeterminacy is, as opposed to how it works. So the kind of strategy I'm employing today is one whereby I attempt to give a reductive analysis of metaphysical indeterminacy in terms of chance. So let's say something very general about indeterminacy. Indeterminacy, very roughly and without having the ambition of providing a general characterization, is typically associated with the absence of a fact of the matter. In particular, we say things like, for it to be determined that so and so, it means that there is no fact of the matter as to whether so and so. So let's just take that as a preliminary characterization. There are many putative cases of indeterminacy that have to do with fission, the Liar's paradox, the continuum hypothesis, obviously vagueness, perhaps certainly the most discussed indeterminacy-related phenomenon, the open future, quantum indeterminacy, and the list goes on. Now, indeterminacy is sometimes attributed to how we represent reality and sometimes not. Some people have argued that indeterminacy is essentially, I don't know why that's a language, you should say representation, sorry, it's a typo. Sometimes indeterminacy has been attributed to certain defective mechanism of how we represent the world in language, and so that leads to semantic indeterminacy, and the go-to theory in this respect is fine supervaluationism. Others, such as Williamson, for example, have argued instead that indeterminacy is a matter of knowledge, or general possibility to know certain facts. So I'm going to set this aside. I'm not going to be interested in representational indeterminacy. I'm convinced that there is some representational indeterminacy, but it is just not today's topic. I'm instead focusing on worldly indeterminacy. So indeterminacy that, and this is just intuition, arises from the non-representational world. So how are we going to understand that? Here is one instance, so just to get, a case study. A case study has to do with time. Consider the statement, it is indeterminate whether Greenland will be part of the US by 2028. It is likely true, arguably true. Why is that? Well, for the following reason, we think, or many of us think, that there is an asymmetry in the structure of time. There is a sense in which the future is open and the past is closed. So facts about the past are fixed, whereas facts about the future are in some sense open-ended or unsettled or not there are many ways in which this asymmetry can be described. It can be described in terms of knowledge, in terms of agency, but the one that I'm interested in is the metaphysical one. And so this kind of metaphysical asymmetry between the past and the future has been indeed understood in terms of indeterminacy. So not only that, but indeterminacy is arguably non-representational, and so metaphysical insofar as if we were to precisify the statement in that, the terms in that statement, we will still get a true statement, or at least on some specification. So the idea is that whether that is true is not because some of the terms in it are semantically imprecise. And this has been also argued by a number of people. Some of them are here in this conference. So I will just be assuming that there is such thing as future indeterminacy, and that what I call future is true. Now there are two theories that have been, at least two kinds of theories that have been proposed, at least two, in fact there are other ones. I'm just going to quickly discuss two of them, which are, I don't know if they're the best theorized, but certainly two of the most classical ones, or the most salient. And these theories are essentially what first theories of metaphysical indeterminacy. One which appeals to revisions of classical logic, and in particular by introducing truth value gaps, and so a non-classical logic. And these truth value gaps are supposed to mirror the existence of indeterminate propositions or states of affairs. And there's another approach which instead proceeds by means of extensions of classical logic, and in particular by assuming that it is determinate that is an intentional operator. I will just be assuming something very standard, which is that it is indeterminate whether phi just means it is not determinate that phi, and it is not determinate that not phi. So let's look very quickly at these standard theories. One is a degree theoretic approach, as I said, in which it is assumed that there are at least three truth values, true, false, and indeterminate. The semantic is truth functional, and the logic that arises is non-classical. Then this strategy analyzes the way determinacy and indeterminacy as follows. So it is determinate that phi if and only if phi is true. Now here is an objection, and the objection is from bivalent indeterminacy. So the statement Greenland will be part of the US by 2028 is indeterminate, as we have assumed, but it is arguably either true or false. It is true if Greenland will be part of the US by 2028, and it is false if it will not be part of the US by 2028. So it takes one truth value depending on how the actual, depending on what the actual future is like. And this obviously cannot be modeled if indeterminacy is taken to be the existence of a truth value gap. There is an alternative approach, the other one that I mentioned earlier, the one that employs revisions of classical logic. On this approach, we say that it's determinate that phi if and only if phi is true in every word with precisification. This is the same kind of approach that Vera was mentioning earlier in her talk. W is a worldly presentification if and only if phi is indeterminately true, then it is true at W. Okay? Now, a metaphysical supervaluationism can account for future. It is bivalent, at least on the standard approaches, so it makes bivalent indeterminacy easy to get. However, it takes determinacy as a metaphysical primitive, so it's part of our primitive ideology. In fact, as you can see, the notion of the worldly presentification is defined in terms of the notion of being determinately true. So this theory, even if it were extensionally adequate, it would still be unable to provide a reductive analysis of metaphysical indeterminacy. Also, let me just say that most likely it is not extensionally adequate because, as it has been argued, it cannot model quantum indeterminacy, but that's another talk. Okay, so now let me talk about my own take on all this. So as I said at the beginning, I think that there is an important connection between chance and metaphysical indeterminacy. In particular, a connection which undergirds what they call indeterminacy cancelling, which is the following thesis, that it's determinate that phi only if the chance that phi is 1. Okay? And we can see it applied in some of, in a number of scenarios. For instance, it's determined that there will be a sea battle tomorrow, hence the chance that there will be a battle tomorrow is 1. It's determined that a particle is in this spatial region, hence the chance that this particle is in this spatial region is 1. All right, so what is my main thesis? My main thesis is that metaphysical indeterminacy is analyzable in terms of chance. Informally, I specify my thesis in the following way. It is determined that phi, if and only if, phi is true, it might not be currently false. Now there are two keywords in the definitions, the might and the currently. Currently, it just expresses a relation of simultaneity. I don't have much to say about that. What does the heavy lifting is the word might. Might is often used mistakenly, as in it might rain tomorrow. That's not how I'm using it here. This might is meant to be objective and also probabilistic. So it's meant to express a chance effect. So the point is how exactly we are going to interpret that might. And I am going to do that in terms of a certain class of models, which I'm going to introduce in a semi-formal way as follows. So first we start with something which I call chance spaces. Chance spaces feature a set W of evaluation points. These evaluation points can be worlds, can be states of a closed physical system, or they can be pairs or triples of any such entities. What matters is that these are worldly entities as opposed to representational ones. So steady states, for instance, are not allowed to be evaluation points in my sense. There is a binary simultaneity relation defined on W. Then we have an algebra of propositions. How exactly what exactly the algebra looks like will depend on specific classes of spaces. I'm leaving this unspecified on purpose, okay? Because I don't want there to be only one correct way in which the algebra should be codified. And then there is a family of probability measures on the algebra, indexed to the points. So the chance at point W that P assigns to the proposition P a chance value at W. Okay. So W will essentially, our evaluation points will be points where sentences have true values or can have true values, and where propositions have chance values. Now, I'm going to define an accessibility relation on the evaluation points, which sometimes I also just call worlds for simplicity. A world or point W prime is accessible from W, just in case for every proposition P. If P has chance 1 at W prime, then it does not have chance 0 at W. Okay, so that means that if these 2 points are accessible, no proposition switches from 1 to 0. So, in a sense, accessibility is so defined, is meant to capture the idea that accessible worlds are probabilistically not too far removed from each other. Our accessibility relation is reflexive and symmetric. I will not say more about this, but philosophers have argued that accessibility relations in the context of metaphysical indeterminacy should have other properties, so this can be a matter of contention. Okay, now given a space, a Chancy space, what is a Chancy model for a sentential language L? It is just a way of providing truth conditions for statements of L at the points of the space. And again, leaving this unspecified because I want this to be a sort of a schematic theory. And finally, we can provide the formal version of my definition of determinacy and indeterminacy. So it's determined that phi at W, just in case, phi is true at W, and it is not false at any accessible and simultaneous W prime. Okay, so let's see how this bears on the case of future indeterminacy. So let's start with certain tree structures that I'm assuming to be finite for the sake of simplifying the modeling. Now these are my, what I'm going to call stages. The stages, you can imagine them as time slices of a world. My evaluation points are pairs, such that the first coordinate is a history in the tree structure, and the second is a stage. So essentially, you can think of an evaluation point as a stage plus a history that crosses that stage. Propositions are sets of histories, and the chance of a proposition P at a point HS is very simply the number of histories in P that cross S divided by the number of all histories that cross S. So if there are two histories that cross S and proposition P contains exactly one of these two histories, the chance at this stage, given any of these two histories, will be 1/2. Okay, so branching models are Occamist models for a tense language. I'm not going to go through the details, but essentially they're ways of assigning in a bivalent manner truth conditions to the statements at each evaluation point. The only non-obvious case is the one of where the main operator is a temporal operator, which works as follows. So in Occamist semantics, there is a function. This function assigns to each stage the actual history that goes through that stage. Okay? So if I say, is it true that there will be a sea battle at some point? Is that true here? Then that is true if and only if at some point in the future, relatively to the actual history, there will be a sea battle. And then the proposition that phi interpreted at a stage, at the point HS is the set of histories H prime such that phi is true at H prime S. All right, now let's go to the main point. So we have a characterization theorem for determinacy. The following two conditions are equivalent. One is that it's determinate that phi at an evaluation point HS, and that for every history H prime, phi is true at H prime S. So that means that take a history and a stage on that history. Okay, and if I want to evaluate the statement, it is determined that, say, there will be a sea battle at some point. Okay, so this is determinately true given my chancing definition, if and only if that is true, no matter which history we pick that crosses. And so my notion of determinacy is in fact extensionally equivalent with the one that we get from Occamist semantics. We also can prove the indeterminacy chance link. So it's determinate that phi at an evaluation point only if the chance of the proposition that phi interpreted at that evaluation point has chance 1 at that evaluation point. Okay, so let's look at some comparisons here. So we have seen that there was an issue with bivalent indeterminacy. Now, relatively to the class of models that we're considering, so the models for tense languages, we have bivalent indeterminacy because semantics is bivalent and the statements can be indeterminate. So in particular, something like it's indeterminate whether Greenland blah 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 will be either true or false at an evaluation point. And yet the statement can be either and then the statement Greenland will be part of the Greenland will be part of the U.S. blah 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 will be either true or false depending on the actual course of events and the actual history that crosses the stage of evaluation. Moreover, the theory does not assume determinacy as a primitive. We have seen that because, unlike metaphysical supervaluationism, which takes the accessibility relation to be defined in terms of determinacy, in our proposal, it has been defined in terms of chance. And so that means that we have addressed both the problem afflicting the degree theoretic account and the problem of afflicting the metaphysical supervaluationist account. All right, so just some conclusion. I have given a sketchy presentation of the Chansey theory of metaphysical indeterminacy, and I provided a sketch of an application. We have seen that the theory provides a reductive analysis of metaphysical indeterminacy. The theory does not, unlike many other contenders, assume a specific logic as the logic of metaphysical indeterminacy, and that's because it is not a logic-first theory. Also, it does not make any contentious assumptions on the semantic side. So in particular, it doesn't assume in general whether semantics is or is not bivalent. We have said that it is bivalent in the temporal case, but there are other applications, such as a case of quantum indeterminacy where it is non-bivalent. Another interesting point is that it doesn't use any hyper-intentional notions. So it doesn't appeal to ground, essence, dependence, or any of that class of notions. And it is informed by a naturalistic methodology, both metaphysically and epistemologically, insofar as chances are bread and butter of natural sciences. And that's it. Thank you.
Use your laptop real quick to display a link. I have my notes here and
My laptop?
Mm-hmm.
Yeah, sure.
Yeah. Sorry if
Sure.
Sorry, I have there's a digital version of a handout. Can I? Sorry,
tell me what you want.
I just want to open a link in a browser to my website. That's possible.
Oh, okay, sure. Go.
Alright. Here's the link to the handout.
Yeah, turn this on.
Alright. I try to provide paper copies, but the printers in the post office let me down, so digital has to do. Thanks Alessandro for this very interesting paper. So Alessandro grounds his account of metaphysical indeterminacy on rather general or ideologically neutral account of chance, which has its advantages and disadvantages. So on this account, chance functions are just indexed abstractly to states or coordinates in a model. To simplify things, I'm going to assume what's arguably the orthodox ideology of chance, where chance functions are associated with world time pairs, where we speak of a chance function at a world at a time. This has been orthodoxy since probably Lewis's paper. Then chancy models, or I think as he called it now, chancy spaces, become rather simple. Chancy space is a pair of a set of worlds and an assignment to all world time pairs. An assignment of a chance function to all world time pairs at these worlds. Chance accessibility also simplifies. Informally, a world time pair is chance accessible from another world time pair if and only if the chance function at the second pair doesn't rule out anything that the chance function at the first pair is certain of. And I don't remember if you addressed this in the paper or not. When I looked over my notes this morning, I was wondering why we chose this route of defining accessibility rather than what would seem like a different but perhaps simpler definition of accessibility, which just uses a positive chance condition where simultaneous chance world pair is accessible from a chance world pair if the first world has positive chance at the second world time pair. It's not on the handout, but I was wondering that this morning, and I just wanted to add that as a question. So determinacy on Alessandro's accounts then amounts simply to the truth and to the non-falsity at all accessible world time pairs. And of course, since accessibility is reflexive, if a world time pair settles all truths, then this simply collapses to truth at all accessible world time pairs. Now, the account strikes me as a fine model of future indeterminacy. And some parts, though perhaps not all of quantum indeterminacy, my two challenges mostly want to press Alessandro's account on whether it is adequate for other subject matters that one might be a determinist about. And the two challenges divide roughly by whether we are naturalist or non-naturalist about a given subject matter. And by naturalism, I just mean a very lightweight notion here, where it's just a global supervenience thesis, where you are naturalist about the subject matter if and only if the totality of all physical facts entails or settles all truths about that subject matter. Good. Now, the first worry arises if you are naturalist about a subject matter, then if there are times at which all irrelevant physical facts about a subject matter or determining a subject matter are necessarily fixed, then Torza's or Alessandro's theory forces that physics determinately fixes the subject matter. But this might be too restrictive. So, to give an example, suppose we are naturalists about morality, then there might be a finite time t at which the chance function at that time necessarily fixes all morality-making facts, i.e. all morality-making facts have trivial chance. Now, there are two main scenarios where this occurs. The first scenario is where the chance dynamics is deterministic. Then it's kind of trivially the case that at any given time all the chances about physical facts are either 0 or 1. The second main case in which this sort of thing arises is if moral truths are necessary. Then it's also the case that at any given time all morality-making facts have trivial chance because, well, if the moral truths are necessary, then the tautologies are moral. Any tautology is a morality-making fact. Good. Now, if there is such a time, then by chance accessibility, any simultaneous chance accessible world-time pair must agree with the given world-time pair on all morality-making facts, and hence on all moral facts. And so by determinacy, any moral truth at that world-time pair is determinately true. But that might well be too restrictive. So suppose, for example, we have a deterministic chance dynamics and we are naturalists about morality in particular. You might think, let's say, moral facts are fixed by convention. And we might still think that even though all physical facts, in particular what conventions humanity adopts as chance 1 at any time, the moral facts that convention fixes might still be indeterminate. Intuitively, a convention might fix a moral fact, but only barely so that in intuitively nearby possible worlds, or with a slightly different convention, different moral facts would have been true. Still, in such case, Alessandro's theory would say that all moral truths are, if they are true, determinately true. Alternatively, if we suppose that moral truths are necessary, then on Alessandro's account it also follows that they are determinate, but many people think that there are that there are necessary truths that are indeterminately true. For example, Schönfield in her paper talks of morality this way, and also the paper that Alessandro cites, the Barnes-Williams paper, they also give examples of necessary truths that they think are indeterminate. For example, the continuum hypothesis might be such a case. And so the first worry is that Alessandro's account doesn't allow these sorts of cases, and so is too restrictive. The second worry, real quick, would arise in the context of non-naturalism. In short, here the worry is that Alessandro's account forces indeterminacy about any proposition whose truth value varies between physically identical worlds and whose chance value is undefined. And these two things, that truth value varies of a proposition varies between two physically identical worlds, and that its chance is undefined, might well be true on if we are non-naturalist about the subject matter that that proposition belongs to. So, for example, if we are non-naturalist about morality, we might well think that there is a determinate moral truth that is merely contingent, and in fact that is false at a physically identical world to ours. And since we are non-naturalists about morality, it's also natural to think that that truth doesn't have any well-defined chance. These are, I think, natural things to expect to happen on a non-naturalist account, but they're incompatible with Alessandro's theory. Alessandro's theory would imply that any contingent proposition that whose truth value varies between two physically identical worlds and whose chance values are undefined can only be indeterminately true. But I worry that will be too restrictive for non-naturalists about the subject matter. Okay, those are my comments. Thank you.
Thank you so much for these comments. These are very helpful and spot on. I do agree that since my theory is presented in terms of chances, there is a worry that it may not fare well when it comes to non-physical facts, such as moral facts, but not only, say, set-theoretical facts. And this is something that I'm considering, that I'm planning to work on that. But let me just focus on the two specific challenges that you raised. So the first one, so in your first worry, you were saying that so you're considering the statement, any 180-day fetus is a moral person, and this is supposed to be actually true, but it may be false in a world where the inhabitants have adopted a slightly different convention, moral convention, and so what I'm thinking about this case is that it's not clear to me that what the conventions in that world look like has anything to do with the truth of the statement in question about the fetus. Because when we evaluate the statement P at the world, the conventions that matter are the conventions that we have adopted in connection to our language, as opposed to the conventions that have been adopted by people at that world. Quick analogy, suppose I take the sentence, water is H2O. It's obviously true in actuality. There is a possible world where people have adopted a linguistic convention whereby water refers to XYZ. So water is H2O is still true at that world as stated by us. And so whatever linguistic conventions people have adopted at that world is irrelevant. So that's one thing that comes to mind. About the second worry, I'm essentially, so I don't think I have objections to the argument per se. So you're telling that there's a problem with a certain class of non-naturalistic ethical theories. Now, one of your assumptions is that for any moral proposition P, the chance that P is undefined, because the idea chances express physical facts, and morality for the non-naturalist is a non-physical fact, therefore chances are undefined for those propositions. However, I would assume that if you're a non-naturalist about moral facts, you may at least consider the existence of moral laws over and above the physical laws. If there are moral laws, there might well be moral chances, and these would be the chances that are constrained by the moral laws. And if that is the case, then it seems to me that there is a way to avoid the conclusion of your argument, which is essentially so that the reason of avoiding the conclusion is the following. So suppose we have our determinate statement P, W. Also, let's assume that given our moral laws, if something is true, then it has chance 1, and has 0, it has chance 0. If it's true, it has chance 1. If it's false, it has chance 0. Then, if it's actually true that P, then P has chance 1. Now you said pick a world where P is false. If P is false, then it has chance 0. So since this has chance 1, here P has chance 1, and here P has chance 0, then these two worlds are not accessible. And if they're not accessible, then you don't have contradiction. So this is essentially what I wanted to say. There are more details, but I don't want to take up more time, so thank you. Sorry. It's not the first time, but sometimes I still get confused.
Okay. Question from the.
So, thank you very much. This is very interesting. I have a very general question. Sorry.
I'll give you that.
Thank you. Okay, so the question is very general. So one of the advantages of the other theories that you've been criticizing seems to be that they are applicable to cases of semantic indeterminacy as well as to things like future indeterminacy. And some people might think that that is a good making feature of the theory because it's very generally applicable. So I was just wondering, would you say that's a drawback of the theory? And if so, is there any chance that, I don't know, you might apply your theory to other cases that people typically classify as semantic indeterminacy? So think of the standard cloud cases and things like that.
So let's see if I understood. So you were saying that the other theories apply to both metaphysical and semantic. So I would say that as far as the degree theoretic account goes, I take that to be only a metaphysical account of metaphysical indeterminacy, because every statement has a determinate truth value, either 1, 0, or whatever. So there is no semantic indeterminacy there. And Williamson has a paper, now classical, from about 25 years ago, where he argues that degree theoretic theories of indeterminacy are theories of metaphysical indeterminacy. As far as the other case of classificational, there isn't really one theory that applies to both the semantic and the metaphysical case. There are just two theories. There is Fine's theory, where we have classification of a language, and then we have the Akiba, Barnes, Williams scenario, and those are actually themselves multiple theories because they're not equivalent, in which we have the machinery of Ersatz worlds in the case of Barnes and Williams, and concrete worlds in the case of Akiba. But I don't see all this as being instances of one theory. They're just theories that have certain structural similarities, but I never thought of them as being the same theory, which is the presentificational notion of indeterminacy.
So I guess this depends on how to individuate theories. So I agree that the various classificational approaches are not extensionally equivalent to each other. Still, you might say, okay, so this approach is in terms of, ontological might be more relevant with similar amongst each other than to the approach that you're proposing. So it seems to be different classes of approaches. Okay. But yeah, okay, I think this depends on how to read it.
So I'm very sympathetic, but I was wondering if someone less sympathetic with it and with in mind reductionist project could object to your position on the ground that the notion of change, of chance, is somehow too close to the notion of indeterminacy itself. So it's the one I wonder whether here we are really like coming out with a reductive account, or just like telling us how the notion of determinacy behave when we think of it in terms of chance. And if one is worried, then one might prefer certain accounts, not the metaphysical relations, because those are not really productive. That's like the one of like Jessica Wilson's, in which it's clear in a sense that the elements, the base of the reduction are conceptually very distinct from the notion of determinacy. So I would say just sort of devil's advocate.
About the first question, are chance and indeterminacy too close for me to claim that I'm actually shedding light on the phenomenon? Well, I mean, it might depend whom you ask, but as far as I know, chance has not been associated with metaphysical indeterminacy. And perhaps only derivatively in the case of quantum indeterminacy, because there are chances there involved. This is essentially what I would say. In general, there. Okay, I'll stop here on this point. About the second point, the Wilson approach. That is an approach that I have not mentioned, and I did it on purpose. It's not by accident. Although I spent a lot of time discussing this with Jessica and other people, something I would argue is that given her approach, there is no good way of defining a determinacy operator. Okay, so what I want is to be able to define a determinacy operator. So in a semantic for it is determinate that. And if you try to do that with her account, disaster ensues. So I think her account might be helpful in some cases, but I think that as a general theory of indeterminacy, it's not going to be very useful, and precisely because we don't have a sufficiently general way of articulating this semantic.
I could interrupt at this stage. So I wanted to ask about, this is a kind of fairly flat-footed, I'm sure you thought about this, but I'm wondering kind of whether we need the chance measures that are going to be used here to come from science. Like, that would be the kind of most naturalistic way of doing it, or whether there's like scope for reverse engineering them in cases where science doesn't give us suitable ones. I'm thinking of like an example where the future is open, but the future is open because everything is chaos, and like nothing is determined to happen next yet or not, but nor is there any kind of systematic order to the world. We've got a kind of lawless world. Then you might think that like there's no laws, maybe there's no laws at all. So there isn't a kind of law specified chance function. in that case just to kind of, you think of openness, so there must be chance. But is that like weakening the naturalism of it? Or maybe you rule out those possibilities?
Well, this would force me to say something substantive about the nature of chances, which also I have avoided on purpose because I tried as much as possible to be ecumenical on that, and so without presupposing maybe what chances are. But here is what I suspect goes on in these cases. So I think that generally there are chances, and we have access to them by means of our studying nature, and we do that by studying the laws. And so the chances and the laws somehow come together. At least if we have something in mind like uses best system, we find out about laws and the chances at the same time. If instead we're primitive, it's about the chances, and there are just the chances, and the laws will give us access to what the chances are. So this is a situation where, in the world where we're lucky. Whereas in a totally chaotic world, I presume that there will still be chances about what, I mean, there's still a chance of something happening, but there is no way in which we can discover that by use of laws. So there are chances, but not laws, or very informative laws that tell us how we can have access to the chances. So yeah, this is something that I suspect might go on in this kind of scenarios. But then again, perhaps it would also be interesting to see exactly what this course look like. So yeah.
So I think kind of a lot of theories of chance, maybe especially the more Humean ones, are quite conservative about when they think about chances. Like the kind of chance theory needs to be good enough before there are any chances at all. Someone like Karl Popper has a specific Humean theory of chance where most propositions just don't get chances at all. And so it might be that you need a very kind of generous theory of chances in the background, but maybe the accounting for indeterminacy of the future might be a reason to adopt such a theory in itself. Again, moving a little bit further away from naturalism maybe, but maybe not so far as to be a problem. Then again, there are like other theories, like the ones which say that like, the chances are coming out of quantum theory, and quantum theory always is going to give us a chance for every proposition, in which case you would be fine, but then limiting to the world with laws like that. Might be fine if that's not necessary, but not like that. So.
No, these are certainly observations that I should take seriously. About the quantum case, so I would say something against myself. So it is true that all the propositions have a chance if we agree that propositions are represented by closed subspaces in a Hilbert space. But one might have a more generous understanding of what propositions are and take any subspace of the Hilbert space to be identified to the propositions, and for the non-closed subspaces we don't have chances. So this might be a reason for me to worry. The way I would reply to this case is by saying that we should simply be naturalist about propositions and deny that there are non-closed subspace-like propositions. But yeah, there are a number of ways in which whether chances are or not